Chuck?
I
Oh,
can't
there we
tell.
go.
Here we go. Got it.
You got
I
it.
think we got it.
Okay.
Are we ready to go? Do I click on the little live red thing? I don't think I have to do that, do I?
No.
You don't have, you just say got it.
Got it. And we're off and running. We're 5 minutes into it, a little late, a little technological difficulties, but that means we'll go 5 past noon today. Today happens to be the 20th of November, and for the next week, our 144th episode, November 20th through the 26th of the SBAU Astro Hour. And I'm Ron Heron, formerly the Baron. Astro Freaks, Stargazers in Santa Barbara, California. As a proud host, it's good to have you on board. Good to be anywhere as long as this. I call it 93 million miles of fun in the sun, Astro Hour, every week at this time. We get together, members of the Santa Barbara Astronomical Unit in Santa Barbara. We're based at the Santa Barbara Museum of Natural History. Check us out on sbau.org. Watch this live on YouTube. And come join us on the first Friday of the month, which will be a week from this Friday, for our general meeting. We have the three local members talk, each 20 minutes, on different subjects related to astronomy and astrophysics. Second Saturday, we do a star party at the museum. This week, there we go. We're reorganizing on screen. We're going to
Bruce. What's going on with Bruce? Okay, there we go.
Are we okay?
Yeah,
we're fine. Keep going.
Long as I'm on the screen. I once met Bob Hope in the Arlington lobby, and somebody came up to me and talked to me while I was talking to him, and he said, "As long as I'm in the picture, I don't care." I'm going to feel the same way. Couple of nebula we'll talk about. One's a real turkey. The other, for you folks having crab for Thanksgiving, there's a crab nebula. We're going to talk about Olber's paradox.
Hey.
What? Oh, Olber, you're the one on that. There is a Mr. Olber. Why is the night sky so dark? Mostly black, except for the little pinpricks of light. Should be brightly lit. We got explanation and a lot of great historic photos of folks in the incredible astrophysics world. Going to talk about heartbeat stars and the Leonid meteor shower, which is still happening. It peaked on Friday. The Needle Galaxy, and some new theories that are fascinating about dark matter somehow being tied into black holes. Let's meet the gang on the screen. Everybody on board, 6 of us. God love you. Jerry Wilson is there on the lower right on mine, our president, till next month, in which case he may continue to be our president.
Oh, yeah.
Well, I'm pretty sure.
I hope so.
What?
I'll
introduce you there, Tim Crawford. You're off to the left. You're the lower left on my screen. Do you have anything to do with the Tuesday night telescope workshops?
No, not much. It's Jerry runs it. I used to. I kept it alive for a long time. The guy in Tom Whittemore, who you probably introduced, he was the guy that started it.
Yeah, well, okay. He's right next to you on my screen. You're married to Maureen, and Tom. Oh no, he's married to Maureen. You're married to Karen.
Yeah,
no, I'm married to Tim.
That was a close. Tom edits our newsletter every month, and he formerly taught science. Had his own lab out at Westmont College. Maureen is his wife. Pat Forgy is Jerry Wilson's wife. Chuck McPartland is our outreach coordinator. He's back. Happy birthday a week ago to his wife, Pat. And he loves his wife, and they went somewhere, God knows, lowered property values in time. She's the merchandise manager, and I guess she's going to stay that through, well, it's an appointed position. You don't elect anybody, but she's running for Colin Taylor. He's my Colin, Captain Walt Brim hat, I call him. He's finally getting out of that job, and he's always loved to talk about it, but he hates coming to meetings. Anyway, next month is going to be great. And who else is with us? There's Bruce Murdoch. Yeah, longtime supporter, telescope enthusiast, par excellence, president of the Santa Barbara Theater Organ Society. Quickly, you got 30 seconds or less. What are you doing? Meeting at the Arlington?
We had an open console last Saturday.
Oh, okay.
Actually, it occurred on the second Saturday. Amazing. Tomorrow is a big day for me.
Oh, yeah?
I had a fall at the Oak Camp Girl Scout thing, April 30th of 2022.
You remember, yeah.
And I finally have got the pleural effusion stopped. That's a long story, and I won't go there.
Okay.
The indwelling catheter that I have comes out tomorrow.
All right.
But on our
Congratulations.
But on our second Saturdays of the month, when we convene under the dark to look at the sky, our party, we have a daytime event with the big organ downtown at the Arlington, right? Or is that just this month? Well, will tell us later.
Well, I guess it just happened to align on dates. The open console is typically the second Saturday of the month, but they got new management down there, and we can't find out until the Tuesday before that Saturday whether or not we can come in that Saturday. So then we might not get it, and we have to move it a week later, etc.
Well, I hope you're all partying over turkey legs this Thursday, and you're with your loved ones and families. And we better talk to President Jerry fast before we lose him. You never know; he could disappear from our screen. It's time to look at the sillies. It's Jerry Wilson's forwarded silly science cartoons, including the talking stick figures who are seated, two of them at a table having dinner. Obviously going way back in time. He says to her, "So, when did you first get interested in early universe cosmology?" She said, "Oh, sometime around Z equals 0.0. What the hell does that mean? Where's the...
That's redshift.
Oh, is that the redshift? Oh.
And it's negligible redshift. It means basically yesterday.
I knew that. I was just testing you.
It's just a different calendar system.
It's missing a zero there in her answer.
Okay.
Okay, blow that up a little bit because this is funnier than hell. I like the flying birds are in formation heading south or north. Migratory bird at the lead is using GPS. You were headed south, your destination straight ahead, and you're going to make a right turn. One of the birds in the back turns upside down and says, "When have we stopped trusting our own sense of direction?" Oh, that's great. That's not Far Side. Here's the old woman teacher versus the young Wright brothers in a classroom where Orville and Wilbur
didn't see this.
That they were a couple of rogues, made paper airplanes before the invention of planes. You suppose they had those before we actually Kitty Hawk?
So Ron?
Yeah?
That just goes to show you that two rights can make a wrong.
Yeah, I've heard that before.
Open this up. Now, this is great. It takes a couple seconds to check this out. Kentucky on the map.
Oh, my God. I've never seen this.
That is, let's see. It's, what the heck did I write down? Some very creative use of your imagination. But there he is, standing on the right side. We got a shot of the chef with his hat, the head, the shirt, and boots, pants, Kentucky Fried Chicken right there. Somebody's really into the drugs. Those damn mushrooms.
Yeah.
How to find
Tennessee? You got to do something. They don't do geography in class anymore.
Yeah.
Yeah, I just got it. There's space horror. Raise that up a little bit. Which one is this one? I'll read it to you. Space horror is the best horror. What's out there? No one knows. Big rocks, creepy things, sticky things, math. My God, stuff on fire, big holes with math in them. Yeah, we hate that math, don't we?
Guy's afraid of math. No two ways.
This one I didn't write anything down to, but one day on Mercury, and there's a picture of Mercury, our innermost planet, lasts 1,408 hours. Or about the same as a Monday on Earth. Okay, now this one is kind of interesting. I didn't really get the joke, but it's a physics student, a night owl, burning the midnight oil. Only one in the high rise who is up, getting ready for the big test tomorrow.
Yep, all the normals are asleep. The physics student is still cracking the book.
Oh, man.
Well, the engineers are the same way. I used to get by on 4 hours sleep when I was in college.
Well, that and some drugs helped you out, I'm sure.
No drugs.
No drugs?
No drugs. Drugs scramble your brain.
Did the hard way. Okay. Here we go. This is another lunar eclipse from the flat earthers. Earth, once again, it's showing a shadow, how they indeed portray us. It's a pancake planet being held up this time by a pair of Asian elephants standing
Three
on
elephants. One of which is facing you.
Yeah.
Oh, is that the one in the middle? That's what the thing in the middle is.
Yeah.
And it's on the back of a sea turtle. And where is this represented in mythology?
This is a kind of mythology, but it's also a story in physics, because there was a lady in a lecture, a popularization lecture on the universe. And I forget who the physicist was that was explaining how things worked. And she said, no, no, no. It's a flat plane held up by elephants on a turtle. And the professor said, well, what's holding the turtle up? And she said, ha, I got you there. It's turtles all the way down.
Yeah, it's true.
Well, it seems like it's probably East Indian, I would
I
think.
don't know where it comes from.
Okay.
Probably just folklore.
All right. If you want to blow this up, then here's the statement in science. If you identify a UFO as a UFO, then it becomes a flying object, just the FO. Unless it's landed, then it's simply an object. Okay.
An object.
You know, except nowadays it's what, APU or UAP?
UAP.
No, it doesn't have the same impact as UFO.
No, it doesn't. You're right, gentlemen.
No.
Lots to talk about this week. Big number 144, Thanksgiving week. Jerry, where do you want to start? The half moon that actually we call a quarter moon. Half the face is covered, and yet we call it a quarter moon. I always get confused with that.
You only see a quarter of the moon.
I know that.
Actually,
you know that.
Tim has as his background, he has a very good picture of the moon.
Yeah.
It's just about a day past what we see here. This Terminator, this is actually the first quarter moon, and it shows it at about 1 o'clock this morning, which we weren't looking at it. But Tim's is a little farther. It's right now. It's got the Terminator's about over here, and you can see Ptolemaeus and
Alphonsus and Arzeco.
Yeah, thank you. And not quite in here yet, but it's a very interesting time.
But now this is the first quarter, and the one behind Tim would be the fourth quarter.
Well, actually, my optics are, for some reason, my image is flipped.
But it's the other half. We're looking at the other half behind your head.
No. It's just telescope. You got to count the number of reflective surfaces in a telescope to see whether your thing's going to be flipped back or right.
Or upside down.
Yeah, or upside down too.
Okay.
Yeah, it all depends on the scope.
Okay, so
I was up late looking at it, but it had set by 1.
Okay.
Yeah.
And I was showing it to a bunch of people here last night.
So my favorite.
So it's optimally placed for outreach because it starts at sunset, high in the sky, and then about midnight at the end of the evening, then it sets. And then so the dedicated among us can take photographs of dark objects from midnight on.
So another half week or so, and we got a full baby, right?
Exactly 1 week from today, we'll have a full.
Yeah.
God, it's going so fast. It scares the heck out of me.
They do.
Well, it's our aging. Things are going. When we were a kid, it would be a lifetime. Remember when summertime seemed as long and it's 3 months as the 9 months of school? And yet we hated going back for the 9 months. But anyway, that's great.
Oh, I had no sense of time when I was young. For me, a summer vacation lasted forever. And school lasted twice forever.
I remember being in the 4th grade and looking at the 8th graders, and my God, they were so far away from me in time. I was never going to get there.
Yeah. I didn't think I could make it into high school. God.
You want time to slow down, get seasick.
What are we seeing here? Is this part of?
This is the last item, Olber's paradox.
Olber, who the hell is Olber?
So this is a graphic that represents ancient philosophy and actually true geometry.
Really?
The farther away you look, you see more stars. Assuming the universe is static and infinite, then the logic goes that as you look farther away, stars will be fainter. And so, but you get to see more of them in a given angular field of view. So everywhere you look, your line of sight will end on a star, either very close or very far away. And if they're very far away, there are a lot of them. And so the sky should be uniformly bright, like the daytime sun. There should be no darkness at all. And the fact that the sky is not bright, it's dark, tells you that the universe is not infinite and it is not static.
Jerry,
and that's all
Jerry,
yeah.
Joe Doyle is texting here, and he's insisting that no, it could be just dust. And I was trying to point out that no, the dust would eventually heat up, and you'd still end up with your bright sky if it were an infinite universe and infinite in time.
Mm-hmm. Okay, so we'll add Joe Doyle to our gallery of rogues here in a minute. So the idea has been puzzling people up until the 1920s. And the original thing was it's been known for a long time, but an astronomer named Olbers is the one that really articulated it, and for some reason it's now been named after him. Heinrich Olbers, a German scientist, and he formulated the thing, why is the sky dark? It's kind of like Fermi's puzzle now, where are they? So maybe we'll figure that one out too. But this one wasn't figured out until the 1920s. Down through the ages, it was assumed to be an apparent impossibility. Drove everybody crazy. In the what is the date on this?
Indico Pleoestes. What the hell does that mean? Cosmos.
Yeah.
That was an ecclesiastical writing trying to discuss that in religious terms.
Latin.
First, this is in the 6th centuries. There was a book that tried to explain this along divinity lines. No luck. So a lot of famous people down through the ages, intellectuals like Edgar Allan Poe,
yep.
Smart people like Lois de Cizot, even smarter people like Albert Einstein. And finally, in 1929, and these are just a bunch of random businessmen that don't look happy. That's when the stock market fell.
No wonder why.
1929, they jumped out of windows, didn't they?
Some these just walked out. So anyway, Edwin Hubble first noticed that the universe was expanding, and of course that's the reason.
Well, it could also it implies not infinite in extent and or not infinite in time.
Yes. So the fact is that the universe is expanding now, and this indicates a redshift. This is actually part of a video that shows this poor little packet of wavelengths starting out when this is small and expanding and turning from blue to red as it gets to the Earth. So the statement is that the universe is still very bright, but it's bright at light wavelengths you can't see. So the sky is dark to our eyes and to our instruments.
Ah, okay.
Except for JWST now.
Yeah. Well, that's still, it can't see all wavelengths. So.
Oh, but it goes up to 25 microns, which is far further into the infrared than other scopes go.
Yeah. Oh, yeah, absolutely.
Jerry, this is really simplistic in my mind, but when you look at the sun 1 AU away, it's really bright, really hot. And certainly during the day, it's not dark. But, if you look at something like Mu Cephei or, Herschel's Garnet star, that's way out there and it's a huge star, it just looks like a little, dim dot in the sky. What I'm getting at is that if this luminosity or magnitudes are not additive, then maybe it is bright for all the multitude of stars in the universe. It's just that our eyes, they're trained to see daylight. So maybe it is bright. In other words, it's not a paradox at all.
I don't know what you mean by not additive. If you have,
I was thinking that if all the stars, in other words, in your first image, the further away you look, the more stars there are.
Yeah.
So that it implies that with all the stars out there, and if light is unimpeded, then the sky should be bright.
But stars.
Maybe it is bright for that luminosity.
The sky, that also, the prediction was that it's uniform. Stars are uniformly distributed. They're not. They're clumped together in galaxies.
Mm-hmm.
Okay, so I guess Tim, that sort of illustration was if you take sort of the average brightness of a star.
Right.
It wasn't trying to sort things out as to the various magnitudes they are. So there is an average brightness to a star, and if you take the uniformity principle that and assume that the universe is infinite in time and space, then the entire sky should look like the surface of a star.
Yeah.
Of your average star.
And remember, this is something, a puzzlement that was thought of and discussed and argued about in ancient Greek philosophy.
But the real distant stars can't reach us in regular light waves. They've turned into infrared or even lower than that, like down into the microwave spectrum.
Yeah, that's right.
Right.
We
And
can
therefore, radio telescopes.
Yes.
But with microwave equipment, you can see the surface of the fireball of the Big Bang. So you're looking back to the beginning of time. That's showing you that the universe is not infinite in time, which was part of the paradox.
Right. And so that fireball that Chuck just mentioned, the microwave background, is looking back to about 380,000 years after the bang. We have another discussion here coming up about there may have been two bangs. But we'll get to that.
Oh, yeah.
Lord, I love these new theories.
This I just added this in because it's a very nice shot of the Horsehead Nebula. This is today's APOD, astronomical photo of the day. So, and it's a very nice shot of the Horsehead Nebula. I wasn't able to figure out which took it, but I assume it because of the star patterns here. I assume it's the Hubble because of the high detail.
Mm-hmm.
And it doesn't have the pattern that James Webb has.
It's a dark nebula, Jerry?
Yeah, it's a Barnard 33, I think, or 32.
Okay.
33.
Yeah.
Yeah.
And that's this one.
And there's stars being created inside that?
Yes.
I don't know. Maybe where it's clumped up enough, there would be, but these are pretty thin trailing areas.
But in the Horsehead itself, that's very dense.
Yeah.
There's some infrared photos of the Horsehead, and it's pretty nearly just transparent.
Yeah.
There isn't
But you
much
do
in it.
see nodules in there of infrared
Oh, yeah.
emission,
Oh, yeah.
which
Yes,
are
you
young
do.
stars.
Yeah.
Right.
Well, let's get to this one.
Crab.
This is a James Webb Space Telescope infrared primarily view of the Crab Nebula, M1. And I keep reflexively calling it a planetary nebula, and then Chuck always points out that I'm wrong, that it's not a planetary, it's actually a supernova remnant. And of course, you can tell that because there's no white dwarf at the middle of the star like there is in the Ring Nebula or many other planetary nebulas. This was a humongous event. And this is the James Webb look at it from, I think about a week ago. And the following is a picture taken by Hubble in 2015. Looks very similar, but you're looking at very different things. And the reason that it's in this collection, let's see, where is that?
If you do zoom in on the Webb picture, you can actually see the shock waves from the rotating neutron star's beam.
Oh yeah, it's got a quasar at the center instead of a white dwarf.
Not a quasar, but a pulsar.
Pulsar, right. Excuse me. Yeah. And that's, yeah. So the thing that it's looking at here is they're trying to figure out what the star was happening in the star beforehand, because it's a close-up look at a supernova remnant. And the James Webb picture is looking primarily at gaseous iron. And the stars, as you know, go up to heavy stars like this goes up through fusion from hydrogen and helium like our sun is doing. And then, but this star was bigger and it could go through subsequent stages until it started burning, producing iron. And that caused the iron doesn't release energy, it absorbs energy. So the counterbalance of the star to the fusion energy coming out and gravity pulling in all of a sudden the fusion energy going out stopped. And so gravity won and the star slammed down on itself, produced very high temperatures, produced a lot of heavy elements, and blew itself up. It's called a core collapse supernova. And so they're looking at the population in the James Webb picture. They're looking at the distribution of iron in here to try and figure out how much iron there was in the total mass of the star.
You know, Jerry, what always gets me in these images and looking at them, of course, you're never going to see this live in a telescope as well as anywhere near as this. But the implosion, it's, you know, it's causing this thing to blow outward, and it's traveling outward at great speeds. But every year, it looks the same.
It doesn't. It's close enough that you take a picture, say 20 years apart, and we have pictures of the Crab Nebula going back to the 1900. You can see it in a movie. You can see it grow.
Okay.
Yeah, Tim, there are, you know, GIFs and movies showing that. Plus, also, there's a close-up of the pulsar, and you can actually see it pulsing. You can see it sending shockwaves out through the gas. So that's happening 33 times a second.
Same with the veil. They have images of that expanding.
You can see that expand, yes, but there's no pulsar there.
That's interesting. I didn't know that.
What do you suppose throws it into 33 cycles a second? It wasn't turning that fast as a star.
Yeah, but Ron, it's an implosion. So the stuff is compressing toward the center, and you're ending up with a neutron star. And it's just like your classic ice skater, you know, spinning and pulling his or her arms in and spinning faster.
Conservation of angular momentum.
Yep. Were there astronomers ancient back 1,000 years ago that saw this happen?
This was in the year 1056.
1054.
1054. You're right.
It's almost 1,000 years.
July 4th, 1054.
Yeah.
Independence.
And
there are recordings of it apparently in Chaco Canyon. The Chinese saw it. It was a major event around the world.
And you could see it during the daytime too, couldn't you?
Yes.
Wow.
And the source of this thing is thousands of light years away. So that's just when we saw the light, right, Chuck?
Yeah.
How far is this away in light years?
I don't know, thousands of light years.
6,500 light years away.
Yeah.
6,500. Oh, wow. And you could see it during the day. That is a big implosion.
Yeah.
In a telescope, a very large telescope, I've seen this thing a lot, with a good filter in a large scope. It just looks like a little splash of milk. Nothing like this.
No, not like this.
Well, it was first observed by William Parsons using a 91 centimeter telescope, which I believe is a 36-inch telescope. And he thought it looked like a crab. And so the name has stuck. I don't think it looks like a crab under any scope I've looked at, but I didn't look at it in a 36-inch telescope.
In his initial drawing, we just visited Ireland and visited, you know, Birr Castle, where he did these observations. And they have some of his drawings there on display. And he made it look like a lobster more than anything else in his drawing.
But it wasn't big enough of a star to make a black hole.
Right. There wasn't enough mass left in the core for it to collapse totally into a black hole.
Now, it started as an implosion, the sudden collapse, and then it ran into shock waves from opposite sides, ran into each other and bounced back. And that's where you get this sudden outflow of material.
But
and also you get when the iron gets compressed in the very core there, the protons and electrons fuse to form neutrons. And that's why you end up with a neutron star. When they do that, they release trillions and trillions and trillions and trillions of neutrinos, which normally don't interact much with matter, but you're producing so many of them that they add to the outflow of the explosion too.
Right. And that's the second. There are two ways, and what they're trying to do is determine between the two ways for a supernova starting. One is what's called a normal core collapse, and one is electron capture to produce neutrons, just what Chuck said. So they're counting up the amount of iron and trying to reproduce through modeling what this star was like and if it had a degeneracy pushback from electron capture.
Now, iron is only halfway up the periodic table. There are heavier natural elements above iron that are made during the explosion?
Right.
Yes.
Some are, but
Microscopic.
most of the really heavy stuff gets made when neutron stars subsequently collide.
Right.
You're kidding. And then some are made by us in a laboratory that don't last long.
We don't make very much of it.
Yeah.
Really?
Not compared to a star.
Not a lot of fermium or californium around. Is cobalt?
It's very expensive to get a hold of.
Is
How
cobalt?
long does the collapse take? I thought it would happen in, microseconds when it finally got going.
No,
No? Okay.
no. I mean, speed of light, it takes 15 or 20 minutes for light to traverse just the size of Betelgeuse, for example.
Of course.
Yeah. Amazing. So Betelgeuse is going to look like this someday?
Yeah.
Mm-hmm.
What do they know, or can they predict what it might turn into in the center? A pulsar, a black hole, a white dwarf? It's all
that depends on the dynamics of the explosion. So I don't know that we can predict that, but the more massive the star is, the more likely it's a black hole.
Uh-huh.
And when it reaches iron, I didn't realize that it absorbs energy and doesn't,
No, it doesn't absorb energy. Well, the reaction takes energy. It does absorb it, I guess, but it stops producing it.
Okay.
And it produces some nickel, which is more massive than iron, but since things have shut off, there's not much time for that process to go on.
And when the star does collapse, after the outrush of fusion energy stops, it crushes down on itself and the temperature goes way up.
Mm-hmm.
And that gives you energy to produce iron and other elements above it that don't produce energy.
How about lead? Is it below iron on the?
No, way above.
Oh, it's above, way above. Iron's 26, Ron.
Okay, so lead gets produced in the explosion.
Some, but mainly in neutron star collisions.
Yeah. There was a chart. We'll look it up and see if we can find it for another meeting. But there's a chart that shows the periodic table, and each little square for the element is colored with a combination of colors. And the colors show where that element was believed to have been produced, either the original Big Bang or a neutron star collision or a supernova.
Oh, wow.
Very interesting.
Yeah,
We've
let's
had
do
it
that.
before,
Jerry.
but we'll dig it up.
And we had a talk on nucleosynthesis many years ago by one of the doctors out at Westmont. I can't remember his name now. But anyway, he had a great little video of nucleosynthesis showing the R process, which goes on in these explosions, the rapid process of neutron capture. And it showed each element as it appeared in the explosion. And it was pretty cool animation.
Was that Winters?
No,
No, it sounds like Summerman.
no, it wasn't Summerman. It was the other fellow that was
The
just
Warren?
before Summerman.
Warren Rogers?
Warren Rogers, that's who it was.
Yeah.
Well, we must have had a lot of neutron star collisions because there's a lot of lead on the surface of the Earth. If it didn't get produced in the massive explosion that gave us our elements, everything except lead and everything above iron, where did that other stuff come from?
Well, some of it is produced in the explosion, Ron, and to us that would look like a lot. But neutron star collisions are the major source.
The thing that's hard for me to understand is all those atoms, and there have to be quadrillions of them, are the same. You'd think it would be scattered among other atoms of elements.
There are isotopes where they have different numbers of neutrons in the nucleus.
Yeah.
Well,
remember, you're just producing nuclei. You're not producing whole atoms. It's way too hot for atoms.
But still, doesn't the star make a whole layer of nuclei that are exactly the same, or is it just a big pea soup of everything? How does it condense and we get gold enough in a flat area or iron enough to make a load in the ground? You know what I'm saying? Does that make sense? You'd think it would be all scattered inside the star.
Well, the star is a layered structure inside. When you get a big star that is having different fusion, it has different fusion of different elements at different layers in the star.
So a layer
generally you produce a range of isotopes, like Chuck was just saying. So it's
in that sense, it's a soup.
It's a what? Soup?
A soup.
Yeah.
I think Ron is kind of more talking about geology, like where it lands on.
Right. Yes.
Yeah.
It's geology.
Kind of
But think about it, Ron, for huge amounts of, there's huge amounts of iron in the earth and there's not that much gold really.
I understand why that is. Gold is higher than iron on the periodic table, isn't it?
Yes.
Yes. Oh, yeah.
Okay, so it's produced
So
in
when the earth was formed, all these things, the earth became molten and the heavier stuff sank toward the center of the earth.
Right.
The question is, how do we still are able to mine things on the crust of the earth up here, like gold and iron in such quantities? And it turns out that these are from collisions in the past, asteroid collisions. Theia that made our moon, didn't leave us intact. Theia had a core too of iron. And so we're a little more mixed up than planets with a simple past. And so we have more of these heavy iron things. But a lot of these are from for example, the probe that is making progress right now to Psyche, the asteroid that's believed to be all metal asteroid. It's believed to be the core of a planetoid that through collision had its outer layers, its crust and mantle stripped away. And this is just the core of a planetoid. So they're going out there to explore that and see if that's really true, because just like looking at the light from Earth, we can't tell a lot about it.
And Ron, when these heavier elements arrived in these meteorites or these asteroid collisions, the Earth's crust had dense areas that were enough, that the gold and stuff, even though it may have been molten in the immediate after effect of the explosion, did not sink all the way to the center of the Earth. So it got trapped in the crust.
Yeah.
So that's why you find ores, veins of ore.
No, I totally understand that. It's just very hard for me to see that all those atoms that are exactly the same, and there's, how small atoms are, seem to collect and make a big wide. They're all the same. They all happen to transfer from the next level lower on the periodic table to that element, and all of them at once got together. They weren't mixed in with all of the rest of the atoms.
Well, they're like Jerry said, the star is like an onion. There are layers of fusion that are going on, making different elements.
Yeah,
so
that's what I'm saying.
They are sequestered basically by their mass.
So they kind of
it might be also thought about like maybe sifting through a strainer.
But by mass.
Yeah.
But there's a lot of violence, the collision that made the moon and the incoming asteroids, craters being made. How in the world do all these elements stay together and form a single layer, and the mother load?
Because you had a molten condition, from the energy of the collision, and the more massive stuff sinks together to the bottom.
Yeah, that seems right.
So, like rocks sink to the bottom of a swimming pool. Yeah. So anyway, there's the Barringer meteor crater in Arizona. Yeah, I'm continually impressed at how close that asteroid came to the visitor centers. But when the meteor crater was first discovered, a guy named Barringer, who was a business tycoon, he bought the crater because he figured that, like other craters, he's going to find a big, massive deposit of iron ore at the bottom of the crater. Mm-hmm. And so they did a lot of, you can still see the shacks down at the bottom of the crater where they were mining for the ore. And they never found a body, a lode, L-O-D-E. They found just fragments, because apparently the thing it was iron, but for some reason it didn't come in, or it didn't stay as one massive body. There's shards all over the place, and it's not really profitable to mine that stuff.
Yeah, he was a mining engineer doing the surveys across that part of the Western U.S. at the time. And everybody thought that was a volcanic feature.
Right.
But he knew about all the little pieces of iron that had been found around. And he figured, I think this is a meteorite impact, and I think I can make a buck here.
Yeah.
And a lot of the iron nickel vaporized, and there are trails of microscopic spherules of nickel iron that go all the way to Kansas from that impact.
Holy mackerel.
Wow. Well, the asteroid 6 miles across that supposedly wiped out the dinosaurs 65 million years ago came with an element I guess we don't have much of on Earth, because that's how they dated this. It's called iridium.
Iridium, yeah.
And it made a layer of this stuff?
Yeah, all around the Earth, a variable density. The closer you get to the Chicxulub crater, the more iridium there is, and farther around the Earth, it peters out to almost nothing.
Along with a layer of charcoal.
Yeah.
Well, what do you know about what do you know about iridium? What's its number?
It's up there.
It's above iron.
Yeah.
Yeah, it's very hard because they used to use it for phonograph needles.
Really? It's a metal. It's a metal then, huh?
Yeah.
Well, they do. Iridium. Interesting, fascinating stuff.
It really is.
Shall we go to dark matter made early, or you
it's number 77?
Oh, it is that high?
Yeah. It's between osmium and platinum.
Yeah, platinum 78, gold is 79, and mercury is 80. Mercury is 80. They all do.
And iridium is 77.
Yeah.
Got to be a lot of neutron stars colliding out there that we're not seeing.
Yeah, and Tim,
well, we're seeing them now.
Yeah,
Yeah.
Tim, you'll be happy to hear that processes like this create unobtainium.
Yeah.
Well, the famous miner name is leverite, which means that if you think it's gold, but when you dig it up and assay it, it's not. So you just leave it right where you found it.
Yeah, and the German miners, when they would find cobalt in the mines, which is sort of not worth too much, they thought there was a little genie going around and turning gold into cobalt. And in German, it's called cobalt.
Is it obsoletium? That's what you called it? I wonder if that's next to obsidian.
Obsidian is right next to unobtainium, Tim.
Unobtainium. That's great. That's great, Tom. I still remember you pulling that on me in the middle of a meeting.
Okay, let's take a detour now.
Okay.
Where are we going?
Honor Thanksgiving. This is the picture of constellation of Orion.
Mm-hmm.
And right down here, there's 3 stars that form the belt. And the naked eye in the middle star of the belt is a nebula.
That's a sword. That's a sword, Jerry.
That's the sword, Jerry.
Oh, sword. Yeah, excuse me. Belt up here.
Yeah.
It's on its side. Yeah.
It's like when Orion got his belt, he didn't really care for it very much. He only gave it 3 stars. So this is the sword, 3 stars. Middle star is actually a nebula.
Mm-hmm.
And in honor of Thanksgiving, someone proposed naming in Astronomy magazine, renaming it the Turkey Nebula. You look at it this way, there's the head of the turkey, and there's its whatever that is that hangs down on the side of its snout.
The waddle.
Okay, yeah. And then there's the fat body, so he's ready.
So Jerry, it's a little tough for me to gobble up this story.
Interesting.
Okay.
Got it.
So now we're going to go to another one. It was hard to present this story.
We're going to talk about
no, not that. No, this. There's no suitable picture for this, and this is just an artist's depiction. But we once had a talk at our club from a guy that talked about dark matter, and he said we really don't know what it is. Of course, we all know that we don't know what it is. But the idea was that we really don't know what it is, that it could be a single particle, which is what we're kind of pursuing. But there's another discussion out there that dark matter may not be a single particle. It may be a periodic table of dark matters, and it might have structure to that world. And they're looking at what they call, there's an article in the abstract, which abstract is it? This is the abstract from Cornell University, submitted October 12 this year. And it's a little difficult to read, and I'm not going to waste time. I'll just tell you about it. The idea is that there may have been really two big bangs. The first one was a bang of the dark matter, where that was created along with its periodic table of particles. And these particles were created during a phase transition, like going from water to steam or from ice to water, a phase transition like that. But the phase transition was the fundamental force of the universe split into four the fundamental forces we know nowadays. And that first splitting, that first phase transition caused a series of black holes that were so massive and operated so fast that the dark energy that made those black holes actually evaporated away through Hawking radiation and are gone. But they were dark matter black holes, and they spewed out this periodic table of dark matter into the universe, and that's what we see nowadays.
Wow.
So it's purely speculative, but they are putting together, when I say speculative, it's not really it is a hypothesis, but they're putting together a mathematical model that does show some promise of accounting for dark matter, assuming that you treat it as a periodic table, not a single particle. So some of the things they have in here, dark phase transition, that's where the fundamental forces split into primordial black holes, which ultimately evaporated before Big Bang nucleosynthesis to reproduce the dark sector particles. The requirement is that all primordial black holes evaporate prior to the second black hole, necessitates high-scale phase transitions and hence high-scale masses of the dark sector particles in the true vacuum. I'm not clear on. Go ahead.
Oh, they should call this the Bang Bang theory. If it's bang bang.
Okay, that's a good thing to think about. Yeah. So they work through the details of it as much as we know about that. We don't have any. By the way, IR operators does not mean infrared here. So it's a very interesting theory. The paper's available too in X-Archive. Let's see, this is submitted.
Well, there's obviously, gentlemen, there's obviously some connection between those two that I never thought about before. They're both invisible. Black holes, can't be seen, and neither can dark matter. They're both heavy on weight, on gravity. So why wouldn't they be intermixed? This is great. This is interesting as hell.
Yeah, it is very interesting.
To Olber's paradox.
But again, it's speculative. That is, you have these bright ideas, like Albert Einstein had, that time is relative and inertial mass and gravitational mass were equal, and you couldn't go faster than the speed of light. And he goes, now what are the mathematical consequences of that? And he derived general relativity. So these people are starting with this speculation and seeing where it goes. Very interesting.
How do they divide up the universe for what's out there? Isn't the black dark matter a larger piece of the pie than regular matter that you and I are made of?
Yes.
It seems to be, yeah. I think our regular matter is about 25% of everything.
Okay. It's about 4%.
4%? Okay.
Actually,
the dark matter is about 25%. And then
okay, that's right.
Dark energy is the rest.
Yeah.
Everything we know about 4%, but the actual matter that we have that we can identify planets and whatnot is about 0.5%.
But dark energy is considered part of it. I thought that was like a force.
Well, it is, but it's just, don't take it too literally. It just means I don't know what it is. It's like English for je ne sais quoi.
Well, you could call it unknowing.
Jerry, one of the I guess theories about why the outer portions of a galaxy spin at a certain rate. It's either dark energy or dark matter. I'm not sure which one.
Dark matter.
Dark matter.
Yeah.
Dark matter.
Yeah, missing matter is as Fritz Zwicky used to say, it was missing matter.
So
Well,
that's
go
ahead.
They've identified a few scattered galaxies that somehow they know they don't have dark matter. They're on their own. How in the world do they do that?
They look at the dynamics of the stars, how they're moving within the galaxy.
You tell dark matter indirectly by how things around it are moving, just like Chuck said.
Yet you can't really see it moving. It's even 1,000 years doesn't make much difference.
No, we can see it moving by Doppler shift.
Is that what it is?
Yeah.
What is this a picture of?
This is a picture of a macho, that's the little star, that is very massive, and it's so close to another giant star that it's causing waves on the giant star. Waves like the moon causes tides on the Earth, but these are much more massive. These are big guys, and the closeness of that macho to the star means that these waves are actually hundreds of kilometers high on the surface of a star.
The little one is not more massive than the big one, is it?
I think it is.
Oh, it is?
Yeah. The macho is a hypothetical thing again. It's not been directly observed or proven, but it's a body that emits little or no radiation. So it's kind of like not dark energy, or mass, but it's sort of like darkish mass.
And I think that picture you showed wasn't really macho. That was the
tidal wave
stars.
Heartbeat star, right?
Yeah.
But the object that's causing it is the macho object.
Well, no, because the machos are these compact halo objects that were proposed for dark matter at first. So, like you said, they don't emit much light.
Right.
I think it's a different concept. Anyway,
that's not an accretion there.
Well, yeah, there is. You can see there's some channeling of the mass going into the other one. It's showing
in
this artist's rendition.
Oh, okay, gotcha.
Well, there's a lot of binaries out there that are on this scale, although the little one, if it's more massive than the big one, then the big one would be going around it more so than the little one going around the big.
The blue one is a blue supergiant with 35 solar masses in an eccentric orbit with a secondary companion that cannot be observed, but is likely an O-type main sequence star of around 15 solar masses.
Wow.
Which
in
means
the most
Wow. And so who's sucking off of who there?
This is actually, it has a macho number, 80.7443.1718. And that's what this is a binary in the LH58 association in the Large Magellanic Cloud.
Oh.
Suppose they'll collide someday?
I don't know. The one star is inside the Roche limit of the other one, but it's not being torn apart, but it's perturbing the big star so much that
well, if you have tidal interactions like that, you're going to have I think lots of angular momentum eventually. And
right.
Wow. But they haven't taken a picture of this.
The star, the little one produces tidal interactions at para-astron, produce immense unstable waves on the primary with a height of 2.7 million miles, or 6 times the radius of the sun. So that's how big the wave is, that it completely crosses the atmosphere.
Yeah, and they're saying the orbit's decaying, so...
Yeah, slowly decaying. Mass transferred from the secondary to the primary star.
Okay, so they will collide.
Yes.
Well, they're transferring mass. It's sort of a slow collision.
Well, the big one looks a little like Earth in that there's white. What's the white clouds? Or just a misprint on the?
That's the tidal waves.
That's the gas. The gas of the big star.
Oh, I see.
When so the big star is overflowing its Roche lobe, which means its maximum stable size, and deposit mass on the secondary, inflating its mass to 24 solar masses. And the primary will eventually go supernova and become a black hole of about 8 solar masses.
Oh, it's on its way to being a black hole.
Yeah.
Got it.
That's a small black hole, isn't it?
And I imagine it won't produce a lot of gold and higher iridium lead. It'll all stay within the black hole. Fascinating.
Yeah. So the two of them together are called the macho object.
Wow. Took one
Watch this space.
Took one from the Latin world. I think macho is short for machismo in Hispanic culture.
I don't know. This is a very nice picture of a very picturesque galaxy, the Needle Galaxy. And it is
Andromeda.
in Coma Berenices.
Yeah, the one in Andromeda is 891, I think.
Yeah.
Oops. So this one is this is in the morning sky. It's about 3 a.m. for this plot from the Sky 6 from Planetarium Software. This will be well placed, as will all of these galaxies, in the evening sky next March. So
Let's say the mice. What does it say?
The mice is a pair of interacting galaxies that somebody thought looked like two mice looking at each other.
Yeah.
What was that? It's the Needle Galaxy, and is it 6544 or 65?
4565.
Yeah.
4,
Thank you. You
Thank
said
you,
close enough. You confused me.
Yeah.
We've got 5 more minutes because we were 5 minutes late, so we're going long. This is fascinating stuff, gentlemen.
Okay.
So
this is very much like our Milky Way that we see at night. This large band of starlight, dim star clouds, and obscuring dust in the way. And you can also see many, many background galaxies in here.
And it has that potato chip flip where
Yeah.
So
I was just noticing
curves up,
that.
curves down. Andromeda has that, and it's believed that our galaxy also has that.
But the one thing we can't find out about this is if it's barred or not.
That one, yeah, I don't know about that.
Well, we couldn't see it. We could be looking at the edge on of the bar, and it just looked like a
Well, the central bulge, if the central bulge is not exactly spherical, then it's probably got some kind of a linearity to it, sort of an elliptic look. And that one doesn't look exactly spherical to me.
I'm sure it's in your talking points. What's the name of this?
Needle Galaxy.
Oh, this is the Needle
Galaxy.
Of course. Why did that? Does science know why it flips off on the side there like a potato chip?
That's usually from interaction with other bodies.
Right.
Oh, something goes by another galaxy, whips by in a few jillion years.
Or they form from accretion from smaller galaxies, and that leaves the twist.
I wonder if in time they line up straight again. We'll never know. Oh,
final topic.
That golden night.
This was prepared for last week when we would have had time to view the Leonid meteor shower. The Leonid meteor shower peaked last Friday. This is a Leonid from 2009, I believe. It's quite a bright, long trail. And not that. Okay. Yeah, but the Leonid meteor shower produces storms every now and then. And this is a depiction of one of those storms.
Yeah.
This
1833. Yeah, that's the
1833.
Yeah.
So it was. This picture was made years later. Does it say that? Anyway, it was made in 1839 from memory, and an Alabama newspaper described thousands of luminous bodies shooting across the firmament in every direction. Observers in Boston estimated there were over 72,000 meteors visible per hour during this remarkable celestial storm. Every
I like to
33
see one of
years,
those
it has
as long
one
as
of
they're
these.
not close.
Yeah.
There was a guy named Don Wimpress out at Kachuma Lake that said he was out on a yacht, a sailboat off Baja, 1,500 miles off Baja in 1966 when there was another Leonid storm.
Mhm.
And, he was out on watch in the middle of the night, and he said he thought the world was coming to an end.
Yeah, that would be something to see, Chuck.
Why do you suppose Steven Spielberg hasn't portrayed this? This would be a great scene in one of his history movies, wouldn't it? One of his sci-fi flicks.
Yeah, yeah.
He
And
could do it.
unfortunately, Jupiter has perturbed the debris stream, so we're not predicted to get another storm level event from this for like another 120 years.
Bummer. I'll have to start taking care of myself.
Yeah.
But have any of you gentlemen caught any Leonids in the last week or two?
So that would mean that I'm not ignoring your question just temporarily. That would mean that 2032 is going to be another potential storm. Happens every
1999, 2002, we had sort of a storm from it. So add 33 to that.
So, okay. So somewhere in the early 30s.
Yeah, but I don't think we'll get a big storm because Jupiter seems to have perturbed that debris stream.
Oh, permanently?
Well, not permanently, but that little bit of it has been perturbed away from us. So,
oh, bummer.
We got to live another 9 years to see it, gentlemen.
No sweat. I'm ready.
I know. Well, are you ready for Thanksgiving this week, gentlemen? Your ladies all cooking the bird, cooking up the bird nebula or whatever
I'm cooking the bird nebula here.
Yeah. Well, gentlemen, it's been awesome. Thank you. And we hope we iron out these technical problems. Thank you, Tim and Tom and Chuck.
Yeah.
And we lost Bruce, but
Bruce left.
he took off. All right. We'll do it again. Next week it'll be number 145. And we'll talk about our giblets leftovers. And thank you very